All right, so when we're looking at solving systems, we've done solving systems graphically. And today we're going to hit two other parts, solving systems with substitution, which is going to become the most important method you're going to be doing for the next 3 years. And then also we're going to review solving systems with, some people call it addition, some people call it elimination. So we're going to kind of do 2 parts here. I have 8 different examples I want to go through, and each one of the 8 allows you to kind of see a different little piece of everything that we're doing. So, first one, we're going to talk about substitution. Key idea with substitution, you need to solve one equation for one variable. So look at your 2 equations. Which one leans towards solving for one variable a little bit easier? Okay, the first one. So let's go off just below here, and let's take this first equation, and let's try to solve it. I'm going to move the y over to the other side.
Wouldn't the second one be easier?
Well, then you're going to have to divide by either a 3 or a 2.
But now you have to divide an 11 by 2.
No, we don't. Now we're going to subtract 11. So here's our first step. First step, solve one equation for one variable.
Why did you move the negative 11?
I did.
But why the y alone?
I want to get the y by itself. Okay? So let's just put it as a goal. Okay, the goal is to isolate one variable. I don't care which one it is. Could be x, could be y, could be a, if you want to be Canadian, whatever it is. All right, so I'm going to highlight this variable y in red, and I'm going to go up to the original problem to the second equation, and I'm going to highlight that variable y also in red. So now I take my value for y, which is 2x minus 11, and I'm going to stick it in to the second equation. So here we go, 3x plus 2 parentheses, switch color to red, 2x minus 11 equals 6. So I replaced the y with 2x minus 11. I substituted. Now we distribute. 3x plus 4x minus 22 equals 6. Combine your x's and add your 22. Pause for a second. Good there. Next step, obviously, is what? Divide by 7, x equals 4. How much of the answer do I have? Half. Give me a little squiggle. Which equation would you say is easier to use to solve for y? The first one. So let's plug it in. 2x minus y equals 11. 2 parentheses, stick in our value of 4, minus y equals 11. 8 minus y equals 11. Okay, 8 equals y plus 11. Subtract 11 and you get what? Negative 3? So supposedly our answer is 4 comma negative 3. Now I'm going to put little number 1 right here, because that means we solved it using the first equation. So what I'm going to do is put another little squiggle line here, and I'm going to check it using the second equation. 3 times 4 plus 2 times negative 3. I'm running out of space here. 12 minus 6 is 6. And what was that supposed to equal? Okay, from the original problem, it was supposed to equal 6. So does it check?
Yes.
Yeah. So what is that? What do I as my answer? 4 comma negative 3. Main goal, isolate a variable, plug it in, solve, take that answer and plug it into the other equation. How many remember this from Algebra 1? Some of us? Okay. All right. It's time to go hunting, I guess. All right, next one, B. I set this one up very straightforward. Which variable are you going to work with?
The first one.
The first one. Why?
Because it's easy.
Yeah, it's already there. It's y equals, all right, so it's already separated. So here we go. 4x plus 3 parentheses. What am I sticking in there? 3x. equals 26. 4x plus how much? 9x equals 26. 13x equals 26. What is x supposedly equal? 2. Squiggle. Squiggle. Leaving room for the check. We're setting up for the check. All right. Which is the easiest one to plug it into? Obviously the first one. So 3 times 2. So it looks like y equals 6. If I solve using the first equation, I must check using which equation? The second. You have to use the other equation to check. So 4 times 2, 3 times 6 supposedly equals 26. So 8 plus 18, is that equal to 26? It certainly is. That means our numbers worked, and our answer is 2, 6. Now, before we go to the next page, had we graphed these, where would they intersect? At 2, 6. So, we could have graphed these, but do these equations lend themselves to graphing very easily?
No.
Not necessarily. So sometimes graphing, Alejandro, is the nicest way to do it. Sometimes using substitution is the nicest way to do it. Substitution is going to be, once again, your primary way you're going to solve stuff as we move forward. Elimination and addition are rare instances where it just happens to happen. Okay? All right, let's move down. Different scenario. What's different? Okay, I'm not using x and y anymore. I'm throwing some new variables at us, c and d. As an ordered pair, Joey, we're still going to do it alphabetically. C is going to be written first, D is going to be written second. Which variable do you want to solve for? D. Okay, so let's take that. Cut your thing up into 3 parts again. 2D equals 8. What does D equal? 4, right? That was easy. All right. 3C plus 2 times 4 equals 2. So 3C plus 8 equals 2. What does 3C equal? Can you do that in your head? -6. So what does C equal? -2. Which equation did I get my second answer in? This was equation 2. Is there any way to solve, or any way to check this one per se? Because I can't really plug it into the other, sorry, that was equation 1. I can't really check it because we already know that D equals 4. So my answer simply is -2, 4. And once again, Joey, like we said, you're going to do this alphabetically. C will come before D, P before Q. Whatever the variables are, always answer alphabetically. Winning question. All right, moving down. Cut yourself up into 3 parts. Once again. What do you think? You want to solve for X or Y? X. All right, Paul, solve for X for me, would you?
So,
I'm assuming you're going to start with this one?
yeah.
Go ahead.
So, subtract 6y
All right.
on both sides. And then it would be x equals -6y plus 2.
Okay. So let's go into the second equation. 5 parentheses -6y plus 2 plus 4y equals 36. -30y plus how much? 10 plus 4y equals 36.
Is that plus 4y?
Yes. So that gives me -26y plus 10 equals 36. -26y equals 26. And if you ever get to this point in a problem where you end up getting the same kind of coefficients as numbers, that is such an indication that you're on the right track. Divide by -26, and what do we get for y? -1. All right, so we supposedly have an answer for y. Let's come over now and solve and use that value. X plus 6 times -1 equals 2. X minus 6 equals 2. X equals 8. I used the first equation to solve, so I have to use the second equation to do my check. So let's look at our second equation, which is 5x, so 5 times 8, plus 4 times -1 equals 36. What's 5 times 8? 40 minus 4. Does that equal 36?
Yes.
It does. So my answer is 8, comma, -1.
14.
Pretty straightforward?
Yeah.
What happens if you check and you don't get 36 equals 36?
Did something wrong.
We made a mistake. All right? Which might happen. All right. Let's take a look at the other type of solving. Now, if I flip all the way up to the top, 2x minus y equals 11, 3x plus 2y equals 6. Coming down here, same equation, except now we're going to solve it using a process called addition. Some people call it elimination. Addition and elimination uses the idea of adding things up vertically, Richard, in order to try to drop something out. Sometimes you have to multiply by a scalar. Do you remember that word? A scalar is a number you put in front of an equation to manipulate it to add things up so they drop out. So look at this vertically right now. Is 2x plus 3x doesn't drop out, and -y plus 2y doesn't drop out. But if this -y right here was -2y, then when we added them vertically, wouldn't it knock out? So what I'm going to do is I'm going to write a little scalar of 2 out to the side. And that's my multiplier. Okay? I'm going to put a little arrow there and write the word scalar. And now I'm going to rewrite my equation. My new equation becomes 4x minus 2y equals 22. And I can't emphasize the 22 enough. A lot of people sometimes will forget to multiply both the left side and the right side. Make sure you multiply both sides by that. Now I'm going to recopy the second equation down exactly as it was written. And now I want you to look at them vertically. Do you see how the y's are additive inverses? Mm-hmm. They are opposite of each other. Mm-hmm. So when you add them up now, you get 7x equals 28. You remember this, Zach?
So hard. Oh, I hated this.
Well, the joy of it, though, is if you can see I need one positive, one negative, then when you add them up, it's so straightforward.
Yeah.
So sometimes a problem, Zach, will lend itself to this kind of a problem. Sometimes it's like, I don't want to do it this way. All right? But now, obviously, what does x equal 4? Okay? So let's draw a line down. Yes, ma'am.
So will it, like on the test, will it say solve using this?
It might. I might give you an option to say, hey, solve this one with substitution, solve this one with graphing, solve this one with elimination. And another one I might just say, you know what, just solve. And you are going to make the determination what is the easiest thing. And that's what we're going to continue to do here is say, what does this lend itself towards? Okay? What does this one lend itself? And so we're going to kind of try to see, when do we go towards substitution? When do we go towards elimination? And honestly, graphing, we're going to go towards maybe 1 out of 100 times in real life. Graphing is a way to get a picture, but it's not a great way to get an accurate stuff for right now. I saw a hand over here.
Well, I was just thinking, like, would something like the system, something we have given, would that work for like all of them?
Oh yeah, you could
could
could graph this.
More difficult.
Right. You have multiple different ways to do things. If I said go home, you could walk.
I could walk.
You could bike.
I don't know.
You could scooter. You could get a ride.
I could drive myself.
You could drive yourself. Okay, so all of those are different options to accomplish something. So we have different options to solving equations. All right, let's just finish this one up. 3 times 4 plus 2y equals 6. 12 plus 2y equals 6. 2y equals negative 6 because I subtracted 12. And I divide by 2 and I get negative 3. Okay?
Wait.
Now I chose equation 2 to solve that with. All right? The reason I chose equation 2 is I just didn't like that minus y. I just was trying to avoid it. So to check this, I'm going to plug it into equation 1. 2 times 4 minus parentheses, negative 3, equals 11. I really want to come back to this little piece right here, and I did this intentionally. Many of us sometimes forget to put our values in, Trevor, in parentheses, and so we miss that minus a negative, and that's where we make an error. And so I'm just showing you here that minus a minus, obviously, Trevor, you know, becomes a plus, and that's where you see it working. So once again, my answer is 4, negative 3. Now, let's briefly flip back up to substitution on page 1. With the substitution, I feel like the substitution has more involved for this problem. Would you agree? Okay, I kind of solved, and then I second step, and then third step, and then check, versus coming down here, seems pretty straightforward. So this is an indication, Grace, where this problem, I feel, really lends itself towards elimination. I was forcing the substitution on it, but you can do it. All right? Let's look at the next one. If you add these up vertically, does anything drop out?
No.
All right. Nothing's going to drop out. Remember, it's the addition method or the elimination method. We don't call it the subtraction method. It's the addition method.
Are you allowed to multiply both of them by something if you...
Yes, you are. That would be what I would call a level 3 problem. A level 1 problem, no multiplication needed. Level 1 problem, I'd call it multiply by one equation. Level, and then they got kind of that final thing, multiply both. But could I drop out the x's here?
Yeah.
What if I multiplied the second equation, folks, by negative 1? So rewrite the first equation exactly as it's written, and multiply the second one by negative 1. Do you see my mistake? I made one intentionally.
Yeah.
Raise your hand if you see it, don't say it. This is a classic mistake.
Yep.
Classic mistake. Madeline, what is it?
You did not make the 6 negative.
Okay, that is exactly right. I did not make the 6 negative. That is the classic mistake, and that's why I made it intentionally, so we could see it and think about it. All right, let's add these up vertically. The x's are gone. Little review on terminology. Those are called additive inverses. The y's are very nicely just down to 1y and y equals 4. That was pretty straightforward. I'm going to use equation 1. X plus 2 times 4 equals 10. X plus 8 equals 10. I think it's safe to say x equals 2. We're going to use equation 2 to check it. 2 plus 4 equals 6. Check. Answer 2, 4. So Grace, like we said, this is an occasion where we're going to use a scalar, but we don't have to use one of them. I think on Friday, I've given you a couple of problems where you may have to use 2 scalars. But your goal is to have one number be a positive and one number be the opposite of it. And manipulate however you need to get that, and then just add them up. So, all right, let's look down to C. Let's actually look at this, our general guidance. It said multiply one or both equations by a non-zero number called a scalar to make 2 of the terms additive inverses. That's that fancy word. Add the equations to eliminate one variable, solve what's left, and use that value to solve. All right. What would you call this? Would you call this an easy elimination problem?
Easy. Simple.
Why?
Because it's already set up for you.
Yeah, do I need a scalar?
No.
Okay, so this is almost like a level 0. Okay? So let's just add these up. It's so easy, I'm going green. 2x equals 16. So x equals 8. In algebra 1, I would have said, so x equals 14, right?
Wow.
Because some people forget how to solve equations in algebra 1. All right, so let's solve. 8 plus y equals 14. What does y equal? 6. So that was equation 1. We check with equation 2. 8 minus 6 equals 2. Nice big check mark. Our answer is 8, 6. So a really straightforward elimination problem. They're not going to get any easier than that. Could you solve this with graphing? Yeah, you'd solve them both for y, you'd get your axes out, you'd find out where they intersect. But 8, 6 is almost off the graph. The benefit of graphing is it's visual. The drawback is it's very limited, Trevor, to what your little window is. You know, if your window is only 10 by 10 and your answer is 32, 7, they're not going to see the answer. All right, option D. Do we just add them up like we did the last one? Do I need a scalar?
Yes.
All right, Moss, you've been awful quiet back there. Talk to me about a scalar. You want to drop out the A's and the B's as your first kind of, you want to drop out the B's, okay? I'm not wild about dropping out B's, because me being a beekeeper, I want to keep my B's. But we're going to let you drop out the B's, all right? It's not as sweet, though, if you drop out the B's. All right, let's drop out the B's. What's your scalar? 3. If you guys are nice, I'll tell you a B story later. All right, 3A, 3B, negative 36. I can't do that again, Madeline, because now I got to multiply here by 3. Do I need to multiply the other equation by anything?
No.
2A or not 2A? All right. It's one of those days. All right, we add them up. 5A equals negative 30. Divide by 5, negative 6. I'm going to go with equation 1.
Wait. Oh, never mind.
Okay. Negative 6 plus B equals negative 12. I always struggle with negatives a little bit, so I need to physically write out my steps. So B equals negative 6. Ooh. That seems suspicious.
No.
It's just when you get the same thing twice, it just always seems suspicious to me.
You should not be suspicious. You should be trusting.
Why is it always the last problem?
2 times negative 6 minus 3 parentheses negative 6 equals 6. Negative 12 plus 18 equals 6. Sure enough, it does.
I told you.
I should have trusted you, Lydia. Should have trusted you.
Krista.
All right. So, negative 6 comma negative 6. So elimination versus substitution. Sometimes it lends itself to one. Sometimes it lends itself to another. Make sense? All right, pretty straightforward. Short assignment here. All right, not a big deal. Hopefully it won't be.
Can you put the problems up on the projector?
You bet.
Betcha.